Hello children, in standard 8 you had a complete science book. In standard 9 you will also get a complete science book, but we will segregate the chapters as according to the sub-subject of science. So there are the sub-subject of science are physics, chemistry and bio. So today I am going to start now one new chapter of physics, that is chapter motion. So before starting this chapter, I just want to clear one thing. I will complete this whole chapter with the help of 3 to 4 parts of the video. So in the first part of the video, I will discuss and I will explain everything, the importance and introduction of this chapter, important terms of this chapter. So first, you can see in the slide, the first definition is written here: motion. From a fixed point, if a body changes its position, then it is said to be in the state of motion. By example, moving of a car on the road, walking a man on the road. You can give the lots of example for the motion. In another side, you can see here the rest. If a body does not change its position with respect to the fixed point, then it is said to be in the state of rest. Just for example, wall, building, you can give the more example for that. But the motion and rest are the relative terms. How can we say that? Let us suppose one example. A man is traveling from a train. In this case, the train is in the state of motion and the man is in the state of rest. Still, the man is completing the total distance whatever the train is completing, as compared to the person which appear outside of the train, just like the farmer is working on the field and poles, roads. So the person is also completing the total distance. So in this case, the person is in the rest, the train is in the state of the motion, then after the person is completing the distance. So this example shows that the motion and rest are relative term to each other. Now the next is types of the motion. So all types of the motion you are already learned in the previous classes. First is rectilinear motion, curvilinear motion, vibratory motion, periodic motion, oscillatory motion. These all are the different types of the motion. Next, some important terms related with the quantity. So there are the two types of the quantity in this chapter: scalar quantity and the vector quantity. When an object is totally defined by its magnitude, that quantity is called scalar quantity. When an object is totally defined by its magnitude, what is magnitudes? Magnitudes may be the magnitudes, it means the size of the object. Then this type of the quantity is known as the scalar quantity. Just for example, you can give the scalar quantity: density, distance, area, speed, temperature, energy, power, all are the scalar quantities. And for the vector quantity in which an object can be defined, totally defined with respect to the magnitude as well as its direction. The quantity which having magnitudes as well as its direction, then this type of the quantity is known as the vector quantity. For example, displacement, velocity, acceleration, weight, momentum. So these all are the example of vector quantity. So in the exam, maybe the question will come, give the example of vector and scalar quantity. What are the difference between the scalar and vector quantity? So you can write easily. Now the second term is distance. The total length covered by an object is known as the distance. Velocity. The total distance covered by the object with respect to the time is known as velocity. Acceleration, the rate of change of acceleration, the rate of change of velocity with respect to the time is known as acceleration. It denotes by A. Some SI unit of quantities are written here. SI unit of distance is meter. SI unit of velocity is meter per second. SI unit of acceleration is meter per second square. SI unit of time is second. SI unit of speed is kilometer per hour. Symbols to indicate the important terms. Initial velocity is denotes by small u. Final velocity small v. Acceleration small a. retardation minus a. So retardation is the negative form of acceleration. Time small t, speed s, length l, distance small d. Now you can see here one numerical. Monica takes 20 minutes to cover a distance of 3 km on a bicycle. Calculate her speed in kilometer per minute, second kilometer per hour, and third is meter per second. So first we will write the formula for speed. Speed is equal to distance by time. So distance is given here 3 km and time is given here 20 minutes. So distance by time 3 by 20 km per minute is the answer of the first. So the next we have to find the answer in kilometer per hour. So we will change the minute into hour. So what we will do? We will divide the 20 by 60. So it will come 1 by 3 hours. So again same formula, speed is equal to distance by time 3 by 1 by 3, that is coming 9 km per hour. In the next is meter per second. I have written the two things. Change to kilometer hour into meter per second. We will just multiply with the given number by 5 by 18. To change meter per second to kilometer per hour, we will multiply by 18 by 5. So you will get your answer like this. Again you can see one more numerical is here. It will help. Same thing we will do as we have done in the first slide, that is speed is equal to distance by time. Here we have to find the distance. So speed into time, we will apply this formula, then we will get the answer. See, in this numerical something is different. A train starting from a railway station and moving with uniform acceleration attains a speed of 40 km in 10 minutes. Find its acceleration. So already I have explained about the acceleration. Acceleration is what? The rate of change of velocity with respect to the time is known as the acceleration. So initial velocity is given here 0 because the train is start at the rest. So initial velocity we will take 0 and the final velocity is given 40 km per hour and time is given here 10 minutes. So we will change the 10 minutes into hour. Now acceleration is equal to change in velocity, that is final minus initial, v minus u, with respect to the time. So we will divide by the time. 40 minus 0 by time. Time is given here 1 by 6. So we will get the final answer 40 into 6, that is 240 km per hour is the final answer. So I have discussed two type of the numerical today. First, to find the speed or the distance, and second, find the acceleration. If the definition is clear, so you can be solve any type of the numerical which is related with this terms. Thank you.